તો બધા
Hello, hello.
Yes, miss, you are audible.
Okay, fine, fine. Thank you, sir. I was just checking that am I audible or not. Okay, okay. Good afternoon, everyone. On the behalf of DY Patil School of Engineering, Department of Computer Engineering and Artificial Intelligence and Data Science, I am Sonal Durgule. Here, extended a warm welcome to our Head of Department, Dr. Pankaj Agarkar sir, and our renowned chief guest, Yogesh Murunka sir, and all the participants who are present here for one big faculty development program on machine learning and artificial intelligence, which will be working from today, 20 December 2021 to 24 December 2021, 2021. The machine learning and artificial intelligence are now part of our day to day life, and it is emerging with full scope in every field: tech, computer science, engineering, physics, mathematics, medicines, agriculture, and many more. The artificial intelligence is working in every field. So, to enhance our knowledge and get touch with current scenario working with machine learning, we are here gathered to attend the workshop. I'm here to give a brief information regarding a resource person. Actually, it is difficult task for me to give a brief information for such a renowned person. Our chief guest, Yogesh Murunka sir. He is the director and corporate trainer in machine learning, blockchain, data science, and big data analytics trainer. He is a director of Bharat Soft Solutions. He is having 10 plus years experience in machine learning and artificial intelligence field. He worked for Capgemini India Private Limited. He has successfully trained more than 300 participants for global certification in data science and big data by Dell. He is global certified trainer in data science and big data analytics. He works on different platforms and technologies like SQL, Hadoop, Python, RNN Studio, and HBase. So we are having such a renowned and versatile resource person with us. I welcome you once again, sir, to provide a brief information about workshop and encourage participants to attend this workshop. I request our HOD, Dr. Agarkar sir, to share his views towards this workshop. Over to you, Agarkar sir.
Hello, I am audible.
Yes, sir.
Yes, sir. Yes, sir, you are audible.
Okay. Okay. Murumkar sir, welcome our DYP SOE again. We are already MOU with you, sir, Center of Excellence in Artificial Intelligence and Data Science. Yeah. So welcome, sir. So now today's topic is the machine learning and artificial intelligence. I just give some idea about the our today's topic. So for if we consider AI application, main application of the AI like customer support using chatbots, expert system, online game playing, intelligent humanoid robot. So these are the main application of AI. So, and another way, if we see the applications of the machine learning like that, online recommended system, Google search algorithm, Facebook auto print tagging suggestions. So these are the applications of the machine learning. So now another thing of this AI, the capability, basic capabilities of AI. AI can be divided into three types, like weak AI, general AI, strong AI. So these are the types of the AI. Okay, now another in terms of machine learning, it also divided three types: supervised learning, unsupervised learning, reinforcement learning. So these are the different types of the AI and machine learning. So now there is a wide scope of the AI. For example, AI is a very wide range of the scope. Okay, AI is working to create an intelligent system which can perform various complex tasks. That is the range of the scope. And in terms of machine learning, it is the machine learning has the limited scope. Okay, machine learning is working with create machines that can perform only those specific tasks for which they are trained. So now these are the difference. Just I elaborate the difference between two. So I again welcome to the Murumkar sir. Now we'll waiting the our today's lectures. Thank you, madam. Over to madam.
Okay. Thank you, sir. Thank you for your valuable thoughts you shared with us. You give us where the AI is applicable and what are the scopes AI is having. Thank you, sir. Thank you for sharing your thoughts. To give guidelines to the participants, what the schedule is for the workshop, what things we will be learning here throughout the workshop, what task will be assigned for us, all that things will be given to us by Mr. Yogesh Mari sir. So to provide a proper guideline to the participant and showing the schedule of the workshop, I'm requesting Yogesh Mari sir to share your views regarding this workshop. Share us all the things which we are covering here during the workshop. So over to you, Yogesh Mari sir.
Thank you so much, Sonal madam. Initially, I would like to tell everyone that we have got 141 participants for this particular FDP. I would like to elaborate one more different thing which has been happened this time. That is, we have participants from Punjab, Rajasthan, UP, Haryana, Karnataka, as well as Delhi. So this has been very mixed reaction from us also, that we have got the participant from entire country. So let us see. I guess this would be a overload to our resource person, but he is definitely capable enough to handle it out. The language and etc. He is excellent in it. So whatever schedule and etc. will be definitely WhatsApp you every time, every day before the start of session. Today also it will be going to WhatsApp. But most important is the attendance that is definitely shared only on Microsoft Teams platform during the conduction of this FDP. Now, I would like to congratulate and also say thanks to the person behind this FDP, that is Professor Vishal Borate sir, for introducing this idea. And we have kept it small, 2 hours session per day. Why? Because it is good to digest little, and whatever the data which will be produced, information, each and everything would be definitely fruitful for us. So we have kept it short and sweet. That's it. That's all from my side. And over to you, Yogesh Burumkar, sir. The platform is yours. Just explain each and everything and let us gain all the knowledge. Thank you.
Uh, Thank you, Dr. Aditya sir. Thank you, Yogesh Mali sir. Thank you, madam. Thank you, Vishal sir. So, thanks for the introduction. So, yes, hello everyone. I hope I am audible to all of you.
Yes, sir, you're audible.
Yes, yes. You are audible.
So, everyone, as Yogesh Mali sir has said, right, he will also tell you the schedule and everything, right, how are we going to link. As and when it is required, he will update on the WhatsApp, right? But what I will do is I will start with the basic agenda, whatever the things which I am going to discuss, right, through these sessions and specifically on this first day. So we have only 2 hours in on each day, right? And maybe many of you might have attended some other sessions or maybe read somewhere, right? As all of you are from, like, all of you are, most of you are actually professionals, right? So I will be expecting some of the things from you, right? The first thing is you people, I hope, are aware about basics of Python, right? That is one thing. Because I will try to show you, like, as much as possible, I will be showing you hands-on, right? That is first thing. So it depends on you actually. Like, if there are questions coming from you people, that is always good, right? Because it should be an interactive, right? Because I will also try, and I will also try to come up with some, let's say, some applications, some projects, real-time projects, as much as possible. That is one thing. So yes, first thing is I want to take at least basic Python. I hope you people are aware about. Anyway, I will be explaining you each and every line, whatever I will be doing here. That is one thing, right? And another thing is whatever the concepts which are required, anyway, we will be discussing it. So from my side, I will try to make it as much as hands-on possible. And from your side, you also try to execute the things parallelly with me. See, executing each and every, if it is not possible every time, I'll be sharing all the notes, right? All the code, theory, mathematics, and other things like if we get a time, we will go and we will try to deploy some projects onto cloud in real time. It totally depends on time. I will try to do that one also. If I try to show it to you for at least one or two applications, you will be able to understand it. Okay, you will be definitely able to understand it. But one thing is for sure, everyone, make sure that you also try it at your end. By chance, if you face difficulty while doing this during the session, no problem, you can ask it on the next day. But trying it out from your end is very, very important. So try to understand, maybe because of time limit, let's suppose maybe I will not be able to solve everyone's difficulty, but from your end you try it, you can post it on the WhatsApp, right? That medium you already have. So my point is, if you ask as many number of questions, that will be good for you, that will be good for me also. That is what I am looking at these 5 to 6 days. Okay, everyone, so I hope you got my point. Now, let me just a minute, let me put the agenda in front of you. Whatever I am going to discuss and the way I am going to discuss, right? So I hope you people are able to see this black screen, everyone, right? So I will just try to put some of the points here related to machine learning and artificial intelligence. So I will try to cover the thing from the basics. As I told you, I will be expecting that you people are aware about basics of Python, right? So what I will do is I will try to start with the concepts like what do you mean by machine learning, right? As our topic itself is machine learning and artificial intelligence, right? So I will start with this particular topic. What is machine learning? What is artificial intelligence? Okay. So in short, we will try to discuss. As I told you, from my side, I will try to come up with as many number of examples as possible. Even we will go and we will try to discuss about end-to-end projects also. See, one project itself will require complete session, maybe more than that. That's why there should be some patience. It might be possible that some of you might be knowing about the things already, so you wait for some time because I will be going with like overall audience, right? So machine learning, artificial intelligence, and then we will try to talk about the terms which are related to these terms, and that is nothing but what is data science, what is deep learning. Even everyone, as artificial intelligence we are going to discuss, so we are going to talk about some of the models related to deep learning also. Right? Some real-time use cases we will go and we will try to come up with the models. Machine learning models anyway we will be developing, but deep learning models also we will talk about it. Okay. So for that we will require some of the frameworks like TensorFlow, PyTorch. Any one of these we can actually make it of. That's why in the group in the morning actually I just WhatsApp to everyone that if possible you just try to come up with Anaconda, Jupyter installed or PyCharm installed. Okay, this is one thing, everyone. Then we will go with the types and the approaches. Okay, maybe types of ML. Okay, types of machine learning. We will see which algorithms come under each type, what type of problem can be solved with the help of those, and some of the basic things. And then we will go and we will try to talk about the first basic algorithm, because to develop model we require some concepts, right? So I will start with linear regression. But see, everyone, in linear regression itself, what I will do is I will try to talk about some of the techniques which we are going to require in other algorithms, right? So here I will be talking about all the basic techniques which we generally require. For example, like now you might be knowing about that we should know what is data cleaning, data pre-processing, right? So how to do it? What are the different steps to do it? What if you have categorical data? What if you have text data? What to do in that case? What if you have more than two categories? What do you mean by multi-collinearity? What do you mean by overfitted model? So like this, there are a number of basic things which we require not only in this particular algorithm, but in other algorithms also. So multi-collinearity is very correct. Okay. What do you mean by multi-collinearity? What do you mean by outlier values? How to handle the outlier values? That's why I will be showing you all these things with hands-ons. But yes, in basic Python will be doing. I will be making use of Python. Okay, everyone, and whole lot of other things we'll talk about here. So it's not like that. See, if I want to go with linear regression, I can finish linear regression maybe in 15 minutes. But we will be going and we'll be discussing these terms and some other terms which we require. Okay. After that, algorithm. If you talk about, I will talk about one more algorithm because this is used for classification. So logistic regression I will go with, and then maybe in coming sessions we will go with decision tree, random forest, and KNN. There are near about 12-13 algorithms generally I discuss about. Okay, but these are some of the algorithms which we'll try to go with. And yes, one of the most important algorithms, that is nothing but XGBoost, extreme gradient boost. This is very important algorithm. And then I will go with clustering also. Okay, so in case of clustering, I will go with K-means obviously. Maybe some of you are aware about this. But there is one more algorithm which is also good, and that is called as DGScan, density-based spatial clustering applications with noise. And finally, I will try to show you how to develop the real-time model. So what I'll be doing is I'll be, let's say, suppose we develop some model in case of machine learning with the help of linear regression. So here I will try to show you how to develop a real-time application, how to create a model into a web application, and how to deploy it onto cloud. Okay, so machine learning model we will try to see, and then we will go and then we will try to deploy it onto cloud. Deployment of that particular model on cloud. So that's what we generally happen. So starting from data fetching till the deployment, everything we will try to see it, right? And then I will talk about some deep learning applications. So obviously, I will talk about some basic things about deep learning. What is TensorFlow, how to make use of it, and how to develop the models. So as I told you people that you should have some patience. Those who are aware about some of the things, right? So have some patience. We will be discussing about these things, and here we will be discussing about some of the real-time models with the help of TensorFlow. Okay, so that's why if it's possible for you, everyone, whatever I'll be sharing, just try to make sure that you execute on your machine, and then you try to come up with the doubts. I'll be happy to answer those ones. Right. So these are some of the points, everyone. I'll be trying to discuss and try to focus on that. And then yes, obviously, as I told you, I will go and I will try to talk about end-to-end project. End-to-end project. Why am I saying it like this? Because see, generally I have seen people, they generally ask question, how to decide which algorithm to use at what time. Let me tell you everyone, let me tell you, that is not fixed. It depends on what type of problem you are solving. It depends on uh, what type of a data you have. And let me tell you one more point, we never depend only on one algorithm. We use at least 5 to 6 algorithms at a time, and then we try to choose the best of that. So that is what I will be showing you here, how to do that. Okay, initially we will be developing the models only with one algorithm. Let's say with linear regression, then logistic regression, then decision tree, then random forest, then KNN, then XGBoost, and so on. But at the end, we will go with the end-to-end project. In the end-to-end project, we will be able to understand that how we actually go and make use of more than one algorithm. Why actually there is a need of studying or knowing about these 10 to 12 algorithms at all? Why we cannot go with only one algorithm? So you will get that particular point here. So that is what I will try to do everyone. And as I said, project, it will be an end-to-end project, so that you will get an idea. So what is required here is basic Python, right? Basic of Python, some basic packages like pandas, numpy, matplotlib, and seaborn, and some basic statistics, mean, mode, median, standard deviation. But at the time of going and discussing those things, like yes, I will be explaining you those points. What is normal distribution, what is standardization, how to achieve it with the help of Python. We will try to discuss about that. Along with this, everyone, I will be using two tools throughout these sessions. One is nothing but Anaconda's Jupyter, right? I'm not saying that you should also use it, but whatever the notes I'll be sharing it in .ipynb file. That is in Anaconda Jupyter. You can open those here only in Anaconda Jupyter, right? So this Jupyter we will require notebook, and I will be using IDE because I will be showing you end-to-end application. So for that I will require PyCharm. Now you have an option also, instead of PyCharm, if someone is aware about something called as VS Code, you can go with this. Maybe if it is possible that many of you are using something called as Spider, you can go with that one also, but I will not prefer Spider because I have experienced that Spider is going to crash after some time. That's why either you go with this or this. I will be going with these two. Okay, in like during the sessions, I will be going with these two. Okay, everyone. And yes, one last point. Whatever I will be discussing, whatever it may be, for each and everything, you will be getting the notes from my side. Right? The way I will be discussing, for each and everything, I will be providing you detailed notes. As I said, theory, mathematics, implementation with the output. So all those things that will be on my part, I will be sharing it. Okay, everyone. So I hope everyone has got my point, right? Everyone is clear till this, and everyone is able to hear me. Fine. Let's go and let's try to discuss with start with this particular thing: machine learning, artificial intelligence, data science, and deep learning. So just to make sure that I'll be discussing each and everything, let me take a picture of this. So we'll be going accordingly, right? That is the only point. So in between, if you have anything, everyone, just let me know in the chat box. Okay, I will go and I will try to answer that. Right. So the first thing is, what is machine learning, what is data science, what is artificial intelligence, and what is deep learning. Let's say one by one we will try to talk about. So obviously this is the point which we'll be focusing on initially. What do you mean by machine learning? Everyone, as I said that I will be expecting that you are aware about some of the basic things already, but still someone is having any doubt, don't hesitate to ask your doubts. Do not keep doubts to yourself, just ask it here itself. So here also I will talk about what do you mean by artificial intelligence. I'm again saying that one can go and one can actually read these definitions, but I'm not talking about definitions at all. I'm just trying to make the things, basic things clear here. So maybe not the definitions which are in the books. I just want you to make you aware about the terms actually. In simple words, with simple examples, we'll go and we'll try to discuss so that we'll be able to differentiate between these things, and yes, we'll be able to compare those things, right? And obviously, one more thing is there, that is nothing but data science. So again, this is nothing new for many of you, but it's like just to start with, right? This is what we'll be going with. So artificial intelligence, everyone, we generally hear this particular term many times because AI is the artificial intelligence, or AI is the bigger umbrella. Everything, whatever is going to come, that will come under AI only. So maybe something like this, if I say that this is artificial intelligence, something like this, if I say that this is AI, so everything else is going to come under AI. Okay. So just let me just. Okay, fine. So what is AI? Now, if as I said, if one goes and one try to search about all these terms, you will find out that there are a lot of definitions of artificial intelligence which are possible. But in simple words, as we want to just start with this particular term and get the basic idea here, I can say everyone, AI is a term which we can say that it is just to enable computers to think. To enable computers to think. In simple words, that's what I can say artificial intelligence is. So to enable computers to think, like what? Like humans, right? That's what AI is. As I said, if one goes, one tries to search about the definitions, if one tries to Google about the definitions, you will get thousands of definitions, obviously. But that is not what I am trying to discuss. I am just trying to tell you these things in simple words, just to understand the meaning. AI is nothing but to enable computers to think like human. Like sir also put some examples, right? There are a lot of examples which are possible. Or otherwise, I can say that you just talk about the domain. You talk about any domain, and you will find out that artificial intelligence is there, right? You talk about anything, driverless cars, AI, right? Robots, AI. Even in case of different approaches of machine learning, we will try to see some approaches where again you will see some examples. I will be talking about that, right? Or even you talk about healthcare domain, education domain, entertainment domain, sports domain, artificial intelligence is there, agriculture, everywhere there is. That's why I said that I'll be showing you some of the real-time projects which we have. So as and when we will move forward with all these sessions, right? In the coming sessions, definitely you will see some of the examples and like where I'll be showing you some real-time projects with the execution. Okay, and I'll be sharing those things with you people. Okay. So artificial intelligence, in short, in simple words, I can say that it is just to enable computers to think. To think like what? To think like humans. So it means to think like humans means obviously there comes brain. So uh, where actually it makes use of that particular term. And there is, or maybe you might have heard about something called as uh, artificial brain or artificial neurons. So like deep learning, when we'll be discussing about it, I'll talk about it. Okay, again deep learning also I'll talk about in short. See, everyone, ML, AI, DL, DS, whatever it may be, each one of these are vast. There is no end to that. No one can say that I know everything about ML or AI or something like that. No, it is not possible because you just talk about the domain, AI is there and there is no end. If someone is muted, just mute please. Okay. So this is what artificial intelligence is in short. Now coming to this particular division, machine learning. What is machine learning? So machine learning basically comes under here. As I said that AI is the bigger umbrella. So whatever the things which you will see like machine learning or deep learning, they will be part of artificial intelligence. As I said, AI is the bigger umbrella. And everything depends on data. You talk about machine learning, artificial intelligence, deep learning, data science, everything depends on data. So what is machine learning again? Again, if one goes try to check out, a lot of definitions are possible. But I will say in simple words, machine learning is just a bunch of tools. It is just a bunch of tools. Or I can say, to be more precise, I can say that it's a bunch of statistical tools. Now, which are those statistical tools, right? For what they are used? To learn. So it's a machine learning is a bunch of statistical tools to learn. To learn from what? As I said that everything depends on data. So to learn from data. So in short, I can say that machine learning is a bunch of statistical tools to learn from data, and that's why without data nothing is possible. If maybe if someone is there who is expert in all these techniques, but there is no data, that person cannot do anything. Data is the oil. That's why many people say that data is the oil. Without data, nothing is possible. Right? So if you do not have data, you cannot go and you cannot train the model actually. So in short, I can say that machine learning is a bunch of statistical tools. And what are these statistical tools? We will just try to list down those things at the end. Okay, we'll talk about some of the statistical tools which you generally need. And anyway, in our model development and in the hands-on, anyway, we'll be making use of all those statistical tools as and when they are needed. And most of the times we need it. That's why it's a data science, right? Or we talk about like whenever we talk about machine learning or data science or AI or deep learning, you need some statistical terms. We will try to just list down some of those things. Okay, so machine learning in short, I can say it's a bunch of statistical tools to learn from data. Okay, that's what in short machine learning I can say, and you can see it's a part of AI. Coming to this particular term, deep learning, everyone, deep learning I can say it will come here, somewhere here. Okay, deep learning. Now, what is this? What is deep learning? Again, it's vast. Deep learning is very vast. Specifically, if you talk about deep learning, everyone, it's like right now, if you talk about current situation, there are a lot of problems which are being solved with the help of deep learning. A lot of them. Okay, so deep learning, if you talk about as compared to this machine learning, let's say it's a much more recent terms. Recent in the sense, in terms of use, I can say. Since 2006-7, people have been making use of deep learning to solve different types of problems. And deep learning is all about making use of, or I can say, deep learning is all about using something called as multi-layered neural network. So, what do you mean by this? Multi-layered neural network. So, we'll try to see what is the meaning of this particular term, neural network. So, deep learning is all about making use of something called as multi-layered neural network. So, let's see what is this neural network? So before that, there is a term called as neuron. So deep learning actually is based on the concept of neuron. So see everyone, maybe you might be living about that like as in human brain, or maybe I can say in human body, there is this biological neuron which is available. Right? It is because of neurons only human body is possible. It's possible for human body to send the signals from one part of the body to another part of the body. Right. So deep learning, if I talk about, it makes use of something called as artificial neuron. Okay, artificial neuron. See everyone, this is just a simple introduction I am trying to do. When I will be starting with this deep learning, introduction to deep learning, at that time I will be showing you some of the examples with hands-on. Okay, so if someone is not aware about it or maybe just reading about it but have some difficulty, so wait for some time. I will be showing you this particular thing and with some of the architectures also we will try to talk about. It totally depends on how you people actually go and respond, how you ask the questions. That is also very, very necessary, because it should not happen that I'm going on talking and everyone is just not getting anything, or maybe you are aware about all these things. It should also not happen. That's why I say that whatever it may be, just let me know. I will always go and I will always try to check it in the chat box. Okay, whatever it may be. So fine. Okay, so I will always go and check this out. Fine. So see everyone, deep learning is all about making use of multi-layered neural network, and neural network is a network of neurons. Basically I can say that it's a network of artificial neurons. So something like this. Suppose there is some image is there, image data is there. Okay, this is the input. So what happens in case of deep learning is this image we are going to pass it as an input to neural network. Okay, so something like this is going to happen, something like this. Okay, so all these nodes, whatever you people are able to see, everyone, these are nothing but neurons. Okay? These are nothing but neurons. So maybe I can go and I can show two layers, and then something like this I can do. So this is the input image and this is the output image. So this particular thing, this is a neuron, this is a neuron, this is a neuron. So network of these neurons is nothing but neural network. And it's a multi-layered neural network. That means there are different layers. Okay, and as many number of layers as there are there actually, it just because to achieve the accuracy. Okay, so when, as I said, when we will go and when we will try to talk about some of the examples, at that time this will make more sense. But for time being, just remember that everyone, deep learning is all about making use of something called as multi-layered neural network, and it makes use of artificial neuron. And this neural network is actually a collection of artificial neurons. So that's why, based on that only, this deep learning is actually divided into different types. So deep learning is basically divided into something called as artificial neural network, then something called as convolutional neural network, and then there's one more thing that is called as recurrent neural network. Artificial neural network works well with image and numerical data, but it doesn't mean that it cannot with image data. Artificial neural network can work with image data also. Generally, I've seen people saying that ANN works with ANN works with only text or numerical data. Yes, obviously, it gives more accuracy in that case, but it doesn't mean that it cannot work with image data. It can. Convolutional neural network, people generally say that it works with image data. Yes, obviously, it gives good accuracy with image data, but it doesn't mean that it cannot work with image or text data. Right? It can work with image or text. It can work with numerical or text data also, but it gives more accuracy with image data. Talking about this recurrent neural network, the best example of recurrent neural network is recommendation systems, Netflix, let's say, right? So recurrent neural network makes use of something called as LSTM, long short-term memory. What is long short-term memory? Again, we will be going and we'll be talking about this particular term when I will start with deep learning itself, introduction to deep learning. Okay? In coming sessions, definitely you will see me talking about these things. I will give a very good example with practical hands-on, right? So at that time I will talk about this. But example, as I given you recommendation system like Netflix, in case of Netflix also you can make use of this. So everyone, talking about deep learning, depending on the use actually you can see that for architecture also we have. So ANN, CNN and RNN. These are the basic types in case of deep learning. And why I earlier said that deep learning is like something which is in which deep learning is something which is actually being used for solving a lot of problems. So right now there is a huge impact of artificial intelligence. People refer to it as Google's AI system. Maybe if you are reading some magazines, you might be knowing about it. People refer to it as something called as Google's AI, right? Google's AI, Google's artificial intelligence system. See, this Google's AI is basically most of the time it refers to Google's deep learning system. That's how this deep learning is very important. So that's why some of the most important advances in artificial intelligence in the last 10 to 12 years have been happening in this small area, which is nothing but deep learning. Okay, and that's why this is very important. And one more point, everyone, you will notice that when maybe those who have already worked with these things, maybe they might have found out that whatever the problems which you can solve with the help of machine learning, most of those problems you can solve with the help of deep learning. But vice versa might not be true always. right? So obviously, deep learning, you can say it's a part of machine learning, which in turn is a part of AI. But deep learning, even though it's a small area, but yeah, it's a very important. It doesn't mean that machine learning is not important. Obviously, it is. But I'm just trying to talk about that there is a lot of work which is going to be carried out in future also. And that's why AI, right? AI is going to be everywhere. AI, you just talk about the domain, it is going to be there, right? That's why you might have heard about like AI as a good feature and so on. Obviously, all these things are part of artificial intelligence. So this is just in short to give you an idea about all these terms and the relationship between them, so that one will be in a position to compare all these things properly. Okay, everyone. So this is in a brief and talking about this particular term, that is data science. So maybe in some cases, even you will see that people will write down data science as a part of AI. That is right, absolutely right, no problem. But to be more precise, we will just try to make it something like this. Maybe those people who have read some books, or they might have come across different views people talk about. That is right. That is not at all wrong. But just depending on some domain, I will try to prefer mentioning data science like this. Otherwise, even if you compare machine learning and data science, most of the things you will see that many of the things are same between data science and machine learning. But to be more precise, I will try to write down data science here. And talking about this, again, if you try to search about data science, you will be able to see that there are a lot of definitions for data science possible. So, in a nutshell, data science is all about understanding the data. So in short, I can say that it is all about understanding data, or maybe I can say that making sense of data. Okay, maybe you might have heard about people say that storytelling. Yeah, it can be used. So making sense of data or understanding data. That is what I can. That is how I can actually define data science in short. Understanding data or making sense of data. Okay, so whether you talk about machine learning, AI, deep learning, data science, everyone you will be able to find out that one thing which is very important between all these things is visualization, or visualizing data is a very important aspect of data science, deep learning, AI, or ML, whatever it may be, right? So this particular term you will be able to see that this is going to play very important role in all these domains, visualization. And yes, one more thing. I was talking about these statistical tools, right? And before that, everyone, now you can see that data science has an overlap with AI techniques. It has some overlap with ML techniques also, but very less overlap with deep learning techniques. And now you can see why it is, because deep learning itself is a part of ML and ML is a part of AI, right? And now coming to this, everyone, statistical tools. Which are the basic statistical tools or fundamental tools, I can say, which are going to be very important, or which are going to be used whenever we talk about all of these things, right? So probability, right? Again, not like you should not be an expert, just basic things you should be aware about probability, right? And then statistics. As I told you, here I will be showing you whenever we are going to read some of the statistical concepts, we will go and we will try to discuss about that. Okay, and then obviously there is like you should be knowing about the concept of linear algebra. Everyone, what am I expecting is just basic things. Otherwise, people will feel that are we should one be an expert in that? No, just the basic things. As linear algebra is there, so matrix algebra is also one fundamental thing one can need sometimes. And obviously, sometimes you will be able to see that there is something called as numerical optimization you might be needing in some of the algorithms. Maybe in case of deep learning, if you go, you will try to see that. Okay, you will definitely come across. Now, obviously, last but not the least, there is something some programming language, right? Computer programming you will need for implementation. Right, so yes, computer programming is also one thing which one should be aware of. So these are some of the fundamental tools, everyone, about which one should have a basic idea. Like, and many of the things we will see that we have already come across these things in our school days. Most of those things. It is just that, like in our mind, we feel that okay, should we be an expert in that? No, it's not like that. Okay. So computer programming, as I'm saying, so there are a lot of options now, right? Here in these sessions, actually, I will be showing you the implementation with Python. But there is not only Python, there is R also. Then there is even C++ also one can make use of. Now there is something called as Ruby. Even Java also one can make use of. Whatever may be the language, everyone. basic concepts are not going to change. Basic things are always going to remain same. They are not going to change, right? And that's why if you are good with your basics, so it's always going to help you, right? It is always going to help. So basic things one should be very good at, and then one can go and one can actually explore on it. That's why I also try to go and talk about the basic and the important things, because there are a lot of things. But based on the basic and the important things, one can go and one can actually explore and learn the things. Even in real time work also, it will not give you things. Okay, one can learn, right? One can learn if you know the basic. Right? And one more point, these are not the only definitions. Whatever I said, these are not the only definitions. Obviously, there are a lot of definitions possible, because as many of you are working, right? So I hope maybe you might be knowing about other definitions also. So I'm just trying to put all these things in a simple way. And as I said earlier also, each one of these vast, there is no end to that, right? So whether you talk about ML, AI, DL, DS, whatever it may be, each one of these things are actually vast, and one by one we will go and we'll try to see what type of problems actually one can solve. So this is in short everyone about all these terms. Now what I will do is I will go and directly jump to this particular concept, machine learning. So we will try to see the approaches of machine learning, and then which types of problems can be solved with the help of those approaches, and then which types of techniques or algorithms can be used. And then we will go for the first algorithm, that is nothing but linear regression. There I will explain the concept and what is line of best fit, and then the implementation of the same, along with some of the techniques, some of the important techniques which we are going to need in other algorithms. So everyone, for linear regression we will require some time, right? For linear regression we will require more time, but once you understand the things in linear regression, all the things in linear regression itself, for other algorithms we will not require much time. That way I will be going into. Okay, so I hope this is till this point everyone is clear, right? So let me just, I'll be sending all these things to you again, as I told you. That's why I'm just trying to go and take the screenshots. Okay, so maybe if you want it, you can always refer along with the notes whatever I'll be sharing with you. All these screenshots also I'll be sharing like this. Fine. I hope till this point everyone is clear. Let me check without anything in the chat box. Fine, there is nothing, so I will expect that till this point everything is good. Okay, but still let me know if you have any doubt or anything. As I said, you can just put your questions in the chat box. Now I will go. Now I will go and I will try to talk about the approaches of machine learning. We will try to start with that. Okay. And here then we will try to see like which are the algorithms possible. So everyone, we will try to talk about this approaches. As our topic itself is machine learning, so we will try to go with the approaches of machine learning. Many people like say that these are the types of machine learning. Yeah, that is also fine. Types or approaches of machine learning, I will say. The first, as sir also said, right, that is nothing but supervised machine learning. So here I want to discuss some of the important terms. Generally, I've seen people generally they are confused. So that's why it's very important to go and to talk about this particular term. Supervised learning is the first approach. Then there is something called as, this also generally we are aware about, unsupervised learning. This is the second approach, everyone. And then generally you will see that even though it is there, but in many books they will mention about supervised and unsupervised only. But there is one more, everyone, and that is called as semi-supervised. Semi-supervised learning is also there. So in our end-to-end project, actually, you will come across this semi-supervised learning. Okay. And obviously, there is one more thing, and that is called as reinforcement learning. Reinforcement learning. So what is supervised learning, what is unsupervised learning, what is semi-supervised learning, and with reinforcement learning, one by one we'll go and we'll try to discuss about all these things with the examples which can be used to solve different types of problems. So see everyone, what is supervised learning and why it is actually called as supervised learning. Supervised learning is also called as, or supervised learning basically is used for labeled data. Okay, labeled data. Now it's a very basic term, label, right? So anyone, can you tell me what do you understand by label? What do you understand by label? Just like, can you share your thoughts? Label, what do you understand by label? Label. As I said, supervised learning can be used for labeled data, right? So what do you understand by label? Anyone? If you people are able to hear me, what is the meaning of label? Anyone? Anyone? What is label? Whatever it is, right, wrong, no problem. Or you don't have any idea, or you have idea but have some confusion or something like that. What is label? Anyone? So it depends on you people how you respond. Okay, so you should also show some interest, everyone. No idea. Okay, Saurav Sharma. Okay, fine. No idea. So thank you for replying. See, so see everyone, what will happen is, like, if I ask you a question, if you answer, so I will get the idea that what you know, what you don't know, and accordingly we will know. As I said, that it should not happen that you people are already aware about some of the thing and I am discussing again the same thing. So I will just go and like just introduce it in a short and then I will move forward. That way it will help me. That is the only purpose of asking you questions. Fine. So see everyone, as I said that this supervised learning is used for labeled data. Now what do you understand by label? Let's suppose I have tabular data. Okay, like simple data we will check, we will get. So let's suppose I have something like employee ID. Okay, then let's say employees education level. Okay, education level on the scale of 1 to 5, out of 5, let's say. Then interview score. Okay, interview score. I should not have written employee ID or ID, just ID. Okay, so education level, interview score, and then salary. Okay, everyone, this is the data which has been given to us. Now, what we want to do is, we have been asked. Okay, so this data is given to you, everyone. I am saying that this is given to you. Let's say we have been given the data of, let's say, 500 people. We have been given the data of 500 people, and so on till 500. Okay, education level of first person is out of 5. Let's say 4, is 3, is 2, is 5, let's say 4, and so on, and so on. Interview score is out of, let's say, out of 10. This person has got 8, 9, let's say 7, 5, and so on. And salary, some salary. So everyone, the data like this, we have been given, right? And we have the data of 500 people, 500 people. So we have been asked to create such a model, to train the model, which will predict the salary of a person based on these inputs. Okay, obviously employee ID is not going to make any difference. So let's say these inputs, education level and interview score. So these are going to be my input column. Okay, these are going to be my inputs. Input columns, or they are also called as independent variables. Input columns, independent variables, or we also called, they are also called as explanatory variables. Okay, explanatory variables. So everyone, education level and interview score, these are the inputs. So we have been asked to develop such a model which will help you to predict the salary of a person based on his education level and interview score. Now we want to create that model, or we want to train that model from this 500 number of records. Okay, so it means this is my output column or output, and this is called as label. So output is given, label is given. Let's say salary of the first person is, let's say, 90k, right, 80k, and so on, and so on. Let's say. So label, so output, label, or we call it as target variable. Okay. There are different terminologies which are used for the same thing. Target variable, or we call it as response variable, target variable, response variable, or we call it as explained variable. Okay, explained variable, and yes, dependent variable. So one and the same thing: output, label, target, response, explained variable, dependent variable is one and the same thing again. So try to understand what we have been asked here. We have been asked to predict the salary of an employee. So what is the output that is given to us? That means label is given to us, and that's why always remember everyone. Whenever the label has been given, we can actually solve those types of problems with the help of supervised learning approach. And supervised learning approach, as it is used for labeled data. So whenever you have labeled data, you can solve that problem with the help of supervised learning approach. This is the example of prediction. Maybe suppose we have symptoms, like we have symptoms of the patients. So maybe if you are aware about a thyroid patient, right? Patients having thyroid, right? Thyroid. So positive or negative, let's say positive or negative. So, so there is something called as TSH level, thyroid stimulating hormone. If you have ever read the reports of the thyroid patients, you might have come across this, right? So maybe everyone. So there again TSH level and different symptoms are there. Let's say symptom 1, symptom 2, symptom 3, and so on. So this data has been given to us. So we want to create such a model. Let's say from this particular data, again 500 patients data have been given to us. Now we have been asked to create such a model which will help us to classify the patient as affected by thyroid or not affected by thyroid, or affected by COVID-19 or not affected by COVID-19, and so on. So it means what, everyone? It means this is the column, right? This is our output column. So here output is given, label is given, target is given, explained variable is given, dependent variable is given, response variable is given. So it is also a labeled data. So this type of problem also can be solved with the help of supervised learning approach. I hope it is clear, everyone, like those who are not aware about what's a label. Label is nothing but the response target output variable. So whenever it is given, it means it's a labeled data, and as it's a labeled data, that means that particular problem can be solved with the help of supervised learning approach. Still, if anyone is having any doubt, you can always ask. I already said. So whatever may be the doubt, basic or whatever it may be, just ask it. Okay, everyone, I hope it is clear to all of you what do you mean by label data. Because if you people are not aware about these basic things itself, then obviously you will not be able to understand the things. Even if some people will be able to create the models, but if you do not create a model with good accuracy, then what is the use? Otherwise, Python has made it very easy, everyone. Python has given us the package like scikit-learn. Just call the package, just use the method present in the package, and then train the model. But if you don't know the concepts, if you do not know some of the techniques, obviously you will not be able to create a good model with a good accuracy. Otherwise, everyone can create the model, right? So everyone understand, supervised learning approach can be used whenever the data is labeled data, and this is also called as parent-oriented learning, or I can say teacher-oriented learning. Now, why is it so parent-oriented or teacher-oriented? Because see, it's simple thing, everyone. Let's suppose when we were kids, right? So when we started learning ABCD, so at that time, what our parents or teacher were doing, they were trying to show us the alphabet. They say, okay, this is A, this is A, this is A, this is A, right? So they were showing us. So output was known. So there was a supervisor, there was a parent or teacher and supervisor. They were showing us. So here the supervisor is the output column. So that's a supervised learning. That's why the name supervisor or supervised learning. There is some supervisor, right? That output label. So in our case, parent or teacher were showing us different images of A. They were trying to draw A, B, C, D, and so on. And after training us or after showing us all those things, in enough amount of data, we can say, let's say. So maybe they were trying to test whether you were able to identify it or not, right? So like the things which happen in exams, right? So that's why it's a parent or teacher oriented learning. That is also called. Some people make up those terms also. But the basic thing is you understand that supervised learning can be used for labeled data, and what is a labeled data I told you. Okay, what is the labeled data? I told you. So I hope it is clear, Mr. Saurabh Sharma, right? So that is clear. But still someone is having any doubt, you can always ask. Even though it's a basic thing, but important and one should be aware of it. That is nothing but supervised learning area. Now, talking about which types of problems can be solved with the help of supervised learning. So supervised learning can solve two types of problems. The first type of problem it can solve is prediction types of problems. Okay, the one example which I have given, predicting the salary of the employee. And the second type of problem which it can solve are nothing but classification type of problem, like classifying the patient as uh, COVID positive or negative, let's say. So it totally depends on what type of data you have also. So classification, prediction, these types of problems can be solved with the help of supervisor. Now, in case of prediction, to solve different types of problems, is for prediction actually we use these algorithms, linear regression. Okay. This is a basic algorithm whenever we talk about machine learning. So, for solving prediction types of problems, one can use linear regression. Then there is something called as decision tree. This also can be used for solving prediction types of problems. Then there is something called as random forest, which actually makes use of decision tree only. And then there is k nearest neighbor, k and n. Then there is support vector machine, and as it's a prediction, we will be using a variant of prediction that is called a variant for prediction, that is support vector regressor. Okay, and then one of the best algorithms is XGBoost, extreme gradient boost. XGBoost is also called as queen of machine learning algorithms. Okay, so that is also really very good algorithm. Right, like this, these are the algorithms which we use for solving prediction types of problems. And similarly, we use other algorithms for solving classification types of problems. That is nothing but logistic regression can be used. Decision tree can be used to solve both the types of problems, classification as well as prediction. Random forest, yes, it can also be used for classification type of problem. Okay, and then KNN is the best algorithm for classification. And yes, one more algorithm I did not write it here actually. I did not write here actually, and that is called as new base. This is also very good algorithm. New base also is good for classification. New base algorithm. Random forest KNN are really good algorithm for classification. And yes, XGBoost even also can be used for solving classification types of problems. Okay, and yes, support vector machine also can be used. So we use support vector classifier. Okay, the variant of support vector machine is nothing but support vector classifier. This is what we actually make use of to solve classification type of problem under supervised learning. So everyone, I hope you understood what do you mean by label data, what do you mean by supervised learning approach. So as I said, in case of supervised learning, we have been given the output as well as the input. So we are aware about the label. Okay, we are aware about the label, and these are nothing but the inputs. So we are aware about the input as well as the output, or I can say a label in case of labeled data, right? So this is what we have even in case of supervised learning. Coming to the next part, unsupervised learning. I hope everyone is able to understand the meaning of supervised learning. Fine. Now coming to the next thing, and that is nothing but unsupervised learning. See everyone, as I said that supervised learning can be used for labeled data, unsupervised learning can be used for unlabeled data, okay, or not labeled, not labeled data. That means we are not aware about the label, we are not aware about the response or the output or the target variable or the dependent variable. So this unsupervised learning basically can be used to solve clustering types of problems. And the meaning of the word clustering is nothing but grouping. It can be used to solve clustering types of problems, and the meaning of that clustering word is nothing but grouping. So which are the algorithms one can make use of everyone for clustering? So k-means is one of the best algorithms and very common algorithm one can make use of for solving clustering types of problems. And there is one more good algorithm, and that is nothing but DB-scan. Density based spatial clustering applications with noise. As I told you, clustering is nothing but what? Clustering is simply grouping the data. So let's suppose all these markers one can consider it as one record, one row, everyone, one record or one row in your data. Okay. So what clustering algorithm does? Clustering algorithm is going to cluster or group this particular data into different groups. Maybe 2 groups, 3 groups, 4, 5, 6, 10, 100. Totally depends on what type of data we have and how many number of groups are possible. So k-means does that actually, or maybe with the help of DB-scan also one can do it. In real time, like in end-to-end project, whatever we will be discussing, actually in that case I will be going with the k-means, because in real time also most of the times we go with k-means. But those who are aware, those people who are generally aware about DB-scan also, they make use of DB-scan even. I have seen people talking only about k-means, but let me tell you everyone, even DB-scan is also really good algorithm. Okay, knowing about this particular algorithm always going to help you. You should have option. Okay, so what happens in case of clustering, everyone? Clustering simply going to divide your data into different clusters. So let's say the data points which are having same like similar properties, they will be in one group. The data points, other data points with similar properties, they will be in other group. So this is nothing but clustering, everyone. This is in short clustering. So see, this is clustering. So each marker, as I said, is nothing but what? One record. Each marker is nothing but one record everyone. So clustering, always remember k-means and DB-scan. We will be going and we will be discussing about k-means algorithm. If we get time, we will go and we will talk about DB-scan. Because of the time, if it is not possible for me to go with DB-scan, but I will make sure that you should be getting all the notes with the coding and implementation. Okay. So that is what k-means, like that is what unsupervised learning, everyone. The data is not labeled. That means we are not aware about the output. We do not know the label. Okay, we don't know label, we don't know response variable. That is nothing but unsupervised learning. Now coming to this semi-supervised learning. Generally in many books you will not find out this. Why? Because it is actually a combination of this one and this one. Supervised and unsupervised. So semi-supervised learning is actually, in short I can say that it is unsupervised learning applied plus supervised learning applied. Okay, so maybe let's say some of the algorithm for unsupervised learning, and then after that on the data applying some supervised learning algorithm, and combination is nothing but semi-supervised learning. And let me tell you even here itself that in our end-to-end project actually we will be doing with this unsupervised learning. There are different approaches to come up with applications or to solve the different problems. Right? One of the approaches is what? To go and to cluster the data first. Okay, and then apply the actual algorithm based on whether you want to solve classification type of problem or a prediction type of problem. Okay, so that's why unsupervised learning and then supervised learning combined it is called as semi-supervised learning. We will be discussing it as we will be implementing. We will be using this particular approach to solve the real-time problem. Okay, so that's what semi-supervised learning is. Right, so it's a combination of unsupervised and supervised learning. Coming to the next and the last type or last approach of machine learning is nothing but reinforcement. So reinforcement learning is also called as feedback based learning. This is also called as feedback based learning, or many people call it as with this particular name also, reward based learning. Okay. Now even most of our problems are actually solved or can be solved with the help of supervised and unsupervised. That's why generally you will not see people talking about this, because this itself is a completely different area. If I want to talk about some of the examples here, so driverless cars, that is one example which will come under reinforcement learning, driverless cars, or maybe at start sir also said, right, robots or robotics, projects related to robotics, that will also come under reinforcement learning. So why this particular thing is also called as, like, see everyone, now even though we will not be discussing about this here actually, because we cannot go and we cannot show the projects like this here. We'll be focusing on supervised, unsupervised and semi-supervised actually, and then maybe deep learning and then the types. But the thing is that in case of reinforcement learning, as I said, that these are some of the examples like robotics and everyone, robotics and driverless car, everyone. Now, feedback based or reward based, why it is called as like this? The thing is, let's suppose this is a robot, right? And now this robot is expected to move one step forward on next instruction. It is expected to move one step forward, but it is moving one step to the right side. That means it is not performing the activity as per the expectation, right? So give negative feedback. Give negative feedback or punish, I can say. Or if it is doing the activity as per the expectation, give positive feedback. Give positive feedback or give reward. Now, what do you mean by that everyone? So that will be taken care through programming, maybe with the help of some, I can say, a flag one can make use of. Why it is done? So that it will remember that particular thing next time and it will not repeat the same mistake. Like the way we were punished, right? We were punished in your child days, let's say by our child or let's say by our parent or teachers. A child were different, like children were punished, right? Let's say. So why? The only motive was we should not be repeating the same mistake again. Something similar, I can. So obviously that will be achieved with the help of programming. So we will be using flags there. The only purpose is that it should not make the same mistake again. Let's say there is a driverless car. Now, if the driverless car sees a speed breaker, right? If a driverless car sees a speed breaker, now what it should do, whether it should break down, right? Whether it should brake or whether it should speed up. So it should slow down the speed, right? If it is not doing that, negative feedback. Do something, some logic you apply, and then you just try to store that particular activity at somewhere, right? And maybe it should not make the same mistake again. Or maybe driverless car, if it is there, and on the red signal, if it is not stopping, mistake, punish, right? Negative feedback. So something like that. So reinforcement learning, it's a completely different, I can say, domain, I can say, or maybe area where one can make use of machine learning definitely. But the thing is that there are very few companies, and now it has increased actually. There are companies like Google and Microsoft, they have already started working with this reinforcement learning. And obviously there are other companies also, they are working with the projects, right? So that's why like you have seen that a lot of scope is going to be there for AI, machine learning and all these things. That is for sure. So everyone, in short, this is what the introduction to all these terms which we will be making use of now. So this one, supervised learning, right? Then unsupervised learning, and then semi-supervised learning, and finally we discussed about reinforcement learning. And one by one we will go and we'll talk about this algorithms. The first algorithm which I will be starting with is linear regression. I will talk about the concept initially, and then we will go with the implementation of that particular linear regression, where you will be able to see that I will be going with Python. I will be making use of Python. So I hope this is clear to everyone till this point, right? But still, if anyone has difficulty, any doubt. So I will just try to. Okay, so what is supervised learning, unsupervised learning, reinforcement learning? We have seen, and these are the list of algorithms. Some of the algorithms actually which I will be discussing about, and I will be starting with linear regression. And yes, what is labeled data, what is unlabeled data, when supervised learning can be used, when unsupervised learning can be used, right? And what is semi-supervised learning? These are some of the things which we have discussed till now. Let me clear this. Now let me go and let me start with linear regression. As I told you, I'll be going with the concept first, where we will try to talk about something called as line of best fit, and then we will try to see how it can be used. Okay. So straightforward everyone, I am going with the first algorithm, linear regression. I already said in between, if anyone need out anything, please let me know. Now, to make you understand about linear regression, we will take a very simple example again. Right? Maybe many of you might have come across this kind of examples already also. But just to start with our discussion, right, just to get the concept here, I will go and I will try to talk about the linear regression. As you people have already seen that linear regression can be used to solve prediction type of problems. Whenever we want to predict something, we make use of linear regression. Let's suppose everyone, I have some data, right? So I have some data about the movie, right? It's a very common example again. I have the data about ratings given by the people for the movie like Bahubali. Okay. Bahubali Part 1. We have some ratings given by people. Similarly, we have the rating for Bahubali Part 2 movie. Okay. This is a very basic simple example, very small data I am taking and a very common example I am discussing here. So everyone, we have been given this particular data. So there are ratings given by people. So out of 5, let's say the first person has given the rating as 4 for Bahubali Part 1. Same person has given the rating as 3 for Bahubali Part 2. Then second person has given the rating as 2, 4. Third person has given the rating as, let's say, 3, 2. Fourth person has given the rating as 5, 5. So 1, 3 and 3, 1. Okay. This is what we have been given. So these are the ratings given by these 6 people to Bahubali Part 1 movie and Bahubali Part 2 movie. Now what we want to do everyone, we want to come up with a model which is going to help us to predict what will be the rating of the person. See, we want to train the model from this data, let's say. Okay, and that model will do what? That model will predict what will be the rating of the person for Bahubali Part 2. If one person gives rating as 3.5 for Bahubali Part 1, so we want to find out this particular answer. Okay, obviously, in the real time, if you think about, these are only 6, 1, 2, 3, 4, 5, 6. 6 records are there. Obviously, 6 records are not enough. Definitely, 6 records only not enough. But this is just to show you a simple example because we want to understand the concept first. And then I will go and I will try to talk about the real time examples for the implementation with some more data. Maybe let's say 500 or 600, 1000 number of records. And in real time, we will go with more than that. Okay. Like end-to-end project, for end-to-end project, we will go with more than that. And again, different types of data. So everyone, Bahubali Part 1, Bahubali Part 2, we have these ratings and we want to answer this particular question. So,
Sir, ask.
yes, anyone need out? Okay, fine. Now, talking about this linear regression, as I said, like I will try to explain the concept of linear regression through this particular example. See, linear regression makes use of equation of a straight line. Okay, and I think everyone is aware about equation of straight line. Right, everyone? Equation of straight line is what? Y is equal to mx plus c, where m is nothing but what? Slope, and this is nothing but what? Y-intercept, and this is the output. Or I can write it down like this: y is equal to anything, any variable you can use, beta 0 plus beta 1x. Okay, or maybe I can write down y is equal to b0 plus b1x. Maybe in different books we will be able to find out different notations they have actually used. Where b1 is the slope and b0 is the y-intercept. Okay, and where x is the input, y is the output. So this is the equation of a straight line area. This is what this linear regression is actually going to make you know. What we want to answer? We want to answer this. So what I will do is, as x is my input, y is my output. So everyone, this is the input column and this is the output column. So we are aware about the input as well as the output. We are aware about the label. We are aware about the dependent variable, target, response variable, explained variable. So it's a labeled data. and as it's a labeled data, that means one can actually solve with the help of supervised learning method. So what I will do is, I will try to declare this as x and y. Okay, Bahubali part 1 rating as x and Bahubali part 2 rating as y. Now, as I said, this linear regression is going to make use of this equation of a straight line. How? So see everyone, y is equal to b0 plus b1x. So I will directly come to the point of the equation that to get the value of y, that is output, to get the value of y, I need value of x. So value of x is here, but we do not have value of b0 and b1. So to find out the value of b0 and b1, right, how to do that? So for b1, this is the equation. Summation of x minus x bar into y minus y bar divided by summation of x minus x bar whole square. This is the equation to find out the value of the slope. Okay, we will not go into detail and discuss about the slope. I hope you people are aware about what is the slope. So this is how one can actually find out this slope. Now, for finding out slope, what I need here? X bar, y bar, x, y. So x and y we have. We need x bar and y bar. So x bar is what? Y bar is what? So everyone, x bar is simply the average of all the values of x, and y bar is also the average of all the values of y. So what is x bar? 4 plus 2, 6, 6 plus 3, 9 plus 5, 14, 15, 18. So average of this 18 divided by 6 is nothing but what everyone see. This is what x bar is. Similarly, y bar. 7 plus 2, 9, 14, 17, 18. 18 divided by 6 is nothing but what? 3. So everyone, you can check that we have got x bar and y bar. Okay, and now one can go and one can find out the value of the b1 easily. So see everyone, I can find out the value of b1 like this. b1 is equal to what I need? X minus x bar whole square. So what I will do is, x minus x bar I need. So what I will do is x minus x bar I will find out. What else I need? Y minus y bar. So I am going to find out the value of b1 by putting all these values in that particular equation. And then what else I need? X minus x bar whole square. This is also the argument. So what is x minus x bar everyone here? 4 minus 3 is 1. 2 minus 3 is minus 1. 3 minus 3 is 0. 5 minus 3 is what? 2. 1 minus 3 is minus 2. And 3 minus 3 is 0. This is x minus x bar. Y minus y bar is what? 3. This 3 minus 3 is 0. 4 minus 3 is 1. 2 minus 3 is minus 1. 5 minus 3 is 2. 3 minus 3 is 0. 1 minus 3 is minus 2. And x minus x bar whole square is what? So this 1 square minus 1 square is 1, 0 square is 0, 2 square is 4, minus 2 square is 4, and 0 square is 0. And what else we need is, everyone, x minus x bar into y minus y bar. So x minus x bar into y minus y bar, right, is also we need. So I will simply do the multiplication of x minus x bar and y minus y bar, that is this 2. So 1 into 0 is what? 0. Minus 1 into 1 is what? Minus 1. 0 into minus 1 is what? 0. 2 into 2 is what? 4. Minus 2 into 0 is what? 0 and 0. So what we need is summation. So summation of these things is what? Summation. So 4 plus minus 1 is 3. And 4 plus 4 is also we not give summation. Summation of x minus x bar. So it will be 8 plus 2 is 10. So everyone, I can find out the value of this b1 like this. 3 divided by 10. And that's why b1 is equal to what? 0.3. So this is what we got. This is how actually we got the value of b1. We got the value of b1. Now from the b1, one can get the value of b0. How? Y is equal to b0 plus b1x. So instead of this y, I can use average value. Here also I will have to use average value. So y bar is what? 3. b0 we want to find out. b1 we got 0.3. And x bar is what? 3. So everyone, if you try to solve this, what will happen is b0 will be 3 minus 0.9 and that is nothing but 2.1. So everyone, the equation of a straight line is going to become how? Y is equal to b0 is what? 2.1 plus b1 is what? 0.3 into x. This is the equation of straight line look like. This is our equation. And now from the equation, from this particular equation, one can find out the value of y given the value of x. Okay. So I will just try to put these things into this a plot kind of a thing. Okay. So if this is x and y, okay. So x is nothing but rating given for Bahubali part 1, y is nothing but rating given for Bahubali part 2. So rating is out of 5, right? So let's say 1, 2, 3, 4 and 5. Here it is 1, 2, 3, 4 and 5. Okay, everyone. Now what I will do is I will put all these points. 4 and 3. X is 4, Y is 3. So X is 4 and X is 4 and Y is 3. Somewhere here X is 4 and Y is 3 somewhere here. Right? Then X is 2 and Y is 4. X is 2 and Y is 4. So let's say suppose somewhere here. Obviously it's not exactly right because I'm just trying to with the hands, right? So 3 and 2. 3x is 3 and y is 2 somewhere here. So I am simply trying to plot the given data. And 5, 5, let's suppose here even somewhere here, 5, 5. And then 1, 3, x is 1, y is 3 somewhere here. And finally 3 and 1. So you can see that we have these 6 points. 1, 2, 3, 4, 5 and this one is 6. Okay. Now what we need is actually we need to predict what will be the rating of that same person for Bahubali part 2 if he has given the rating as 3.5 for Bahubali part 1. This is what our question is for that we want to create the model. So I am trying to tell you what will happen in the backend when we will be making use of linear regression to solve this type of problem with the help of that particular method available in the Python or maybe in other language. Maybe someone might not ask you to do all these things while implementation, but everyone, this is very, very important to understand the concept. That is only going to help you to tune your model, to increase the accuracy of the model, to work on the models which are already developed. Okay, so line of base fit is something which is used by linear regression, line of base fit, or we call it as base fit line. Now what we will be doing is we will try to come up with line of base fit. So as it's a line, so obviously it will require 2 points, right? It requires 2 points. 1 point we already have everyone. And what is that? That is nothing but average x bar and y bar. So what is this? Is 3. So what I will do is I will simply go and I will simply plot that point here. See here, x bar and y bar. This is what? X bar and y bar. 3, 3. Okay, 3, 3. But we want to come up with a line, and for line we require 2 points. So another point is nothing but, see everyone, we have b0 plus b1x, right? So the value of the b0 is nothing but what? 2.1, and b0 is nothing but y-intercept. Y-intercept is nothing but the point at which it cuts y-axis. So it is cutting y-axis at 2.1. Let's say 2.1 is somewhere here. So let's say this is 2.1. So I got 2 points. I can draw a line which is going to pass through these 2 points. I can draw a line which is going to pass through these 2 points. And let's suppose that line is something like this. Okay? So something like this thing. Just assume that that line is passing through those 2 points. Okay. So yes, this particular line is called as line of base fit. Now we can answer any type of question. What we wanted, what will be the rating given for Bahubali part 2 is the rating for Bahubali part 1 is 3.5. So for 3.5, let's say this is 3.5. What we'll do is draw a perpendicular line from line of base fit to this line. And then project that particular point, that respective point on the y-axis. And wherever it is going to cut the y-axis, right, that particular is going to be your answer. So the answer is going to be 3.2. Answer is going to be 3.2. This is what is going to happen in the case of linear regression. So this particular line, which we are come up with actually, this particular line is called as line of best fit or best fit line. And always remember everyone, best fit line always passes through dense area. It means wherever there are a lot of points, through that area it passes. Or I can say in such a way that the distance of all the points from the line of base fit is as minimum as possible. Which distance everyone? This distance. This distance. Okay? This distance or maybe this or maybe this distance. Distance of all the points from the line is as minimum as possible. So this particular distance, this one. Maybe this one. It should be as minimum as possible because everyone see, these are our original points. Okay, all these are nothing but original values, and whatever we will be getting on this line, these are nothing but the predicted values. So this particular distance, everyone, this distance d, whatever I am trying to show you to you here, this is actually called as uh, residual. This is called as residual, okay, or I will call it as error, and that's why it should be as minimum as possible. So it means what, on this line whatever is coming, that is going to be the prediction by our model, and this is going to be original value. So the difference between the original value and the predicted value is going to be what? It is going to be an error. So generally, see everyone, this is nothing but what? Predicted. So I will name it as, let's say, y predicted, okay, y prediction, and this will be, let's say, y, or I will denote it like this, y predicted, I will denote it like this, y cap. So y cap is going to prediction. So the difference between y and y cap, y minus y cap, is called as residual or the error. Now if I want to calculate the total error, what will happen? I will go and I will try to add all the errors, but see everyone, that is also not possible, or that will not be good actually. It will not give the idea about total error. Why? Because see everyone, in this case, let's say y and y cap, right? So in this case, y is positive, y is greater and y cap is less. So let's say y is 4 and y cap is, let's say, 2.5. So 4 minus, see, this is 4 and let's say this is 2.5. Original value is 4, predicted value is 2.5. So 4 minus 2.5 will be getting some positive value, right? But everyone, can you check it here? Let's say this one. Original value is 1. Okay, original value is 1 and predicted value is 2.5, let's say, or 2.4, whatever it may be. So it will be what? 1 minus 2.5. So it will be getting negative value. So if I want to calculate the total error, going and adding all these values will not make any sense, because positive and negative errors are going to nullify each other. And that's why everyone, that's why what we do is, we try to calculate, whenever we want to calculate the total error, definitely we will go and we will sum up everything. Y minus y cap we will sum up. But along with that, y minus y cap we will sum up. But if I do it like this, positive and negative errors are going to nullify each other, and that's why what we will be doing is, we will be going and we will be taking the square of this. So this is called as a residual square. Okay, residual is nothing but what, everyone? Error. R square, and this will be denoted as R square. Okay, so linear regression or any other prediction model, any other algorithm, whatever we are making use of, let's say, many of the algorithms you will see that they make use of R square statistics to check out how the model has actually performed. Whether the model has performed good or bad, right? So we will be making use of R square statistics. Yes, Bharti Sahu madam, I think this recording will be shared by the organizers. Don't worry, okay? They will be sharing. And I think I will ask to share this link also. I will share the link also. Okay, fine. So everyone, you can see that this is called as residual. Why am I telling you all these things, everyone? Because now in implementation, many people are going to come across all these terms. Residual is nothing but error. Why R square statistic it is called as? Because we take the square of the residual. And why do we take the square of the residual? Just now I told you. Because if you do not take the square of the residual, you will not be in a position to get the proper idea about error or the residual. And that's why we actually take the, that's why the residual square is taken, or R square is taken. Okay, so I hope everyone has got this particular point, but still if anyone is having it out, just let me know. Now everyone, after this, if I go and if I try to show you in my notes, if I try to show you some of the basic things, many of those things you will be able to make sense. If you have understood whatever I talked about, like what is line of base filter, right? What is residual? Why do we actually go and take the square of the residual? Right? What will happen if you do not take the square of the residual? All those things, everyone, you will be able to make sense. If you have understood the things, whatever I have just now talked about it here, right? So you can check it everywhere, right? These are some of the things which will require in case of, not only in case of linear regression, but in other algorithms. Yeah, basically we are discussing about linear regression. That's why I just tried to discuss about something called as line of base filter. And one more thing, everyone, why actually we are able to say that we will be able to predict output about any value? You can see everyone from this particular graph. If you look at it, this is a straight line, right? This is a straight line. So this straight line is not going to be like this. The nature of the straight line is always straight. It will not go and it will not be like this, right? That's why for whatever the value you now ask, so for whatever the value of the x, you ask the value of the y, you will be getting the value of the y, because the nature of the straight line is always going to be straight like this, right? That's why equation of straight line, that's how we use. So that's how this base fit line comes into picture, and internally this is how linear regression is going to help you to create the model. I will be showing you the trained model also. As I said that if I wanted to go and just show you the implementation of the linear regression, I can go and I can directly make use of a method called as linear regression directly. Yes, one can go and one can actually directly try that. But the thing is that this you should understand, because what will happen because of this? Because of this, you will be in a position to understand the parameters which are present in the linear regression method, and when you want to increase the accuracy of your model, you will be able to do that with what you can say by tuning the proper parameters. And that's why understanding all these things is very, very important. So hope it is clear to everyone. Okay. Now after that, one last point is, with the help of all those things, then it is going to come up with something called as standard error of estimate. Okay. So something called as standard error of estimate. Okay. And in case of implementation, we come with R square statistics actually. So it is found out like this. As I said, under root of maybe y minus y cap or y cap minus y, whatever you want to do. So y minus y cap whole square, take summation of this, and we divide this with the help of n minus 1 or n minus 2, if n is nothing but number of records. Okay, so this is all we find. So whatever is the y, we take the sum up of all those things, right? So for every record we find out this, and then you will get some value, and that is going to be standard error of estimate. Ideally, it should be less than 1. Okay, it should be less than 1. So yes, everyone, these are some of the things which I wanted to discuss about before starting with implementation. Now we can go and I can show you one by one. I can show the implementation. So everyone, as I said, we will be starting with the linear regression itself. And one more point, I said that for linear regression, you will find out everyone that some more time we will require, because there are a lot of things, the techniques also I will be discussing in linear regression. So whatever the file I am showing you, everyone, it's a IPYNB file. I have opened it in Jupyter Notebook, and after this point onwards, you remember that whatever the notes I'll be sharing it in a Jupyter Notebook. When you will get these files in the WhatsApp group, I'll be sharing everyone. When you will be getting this particular file, you will be getting a zip file. Okay, you need to unzip it. Okay, something like this you will be getting. You just need to unzip it. Once you unzip it, you will be able to see a folder, and you need to open that particular folder through Jupyter. I'm just telling you that because after people should not have any problem in referring the notes as well. Okay, so everyone, you can see that in this thing I have starting from data fetching, everything I have actually explained you, and actual implementation is this is not the actual implementation of linear regression with some problem statement. The actual implementation is somewhat later actually. See these concepts, this is what I had discussed with you now. What is residual? Right? There is some mathematics behind that. We take the derivative, what is the purpose of taking the derivative, all those things I will be discussing every. Then what is gradient descent, how to make use of it. So whether it's a machine learning or deep learning, we require this particular concept that is called as gradient descent. Okay, so these notes itself, like they are self-explanatory, but yes, one needs to spend some time. Okay, so R square, adjusted R square, and then how to interpret. Again, here also we have not started with implementation of the problem statement. This is line of best fit, model confidence. Hypothesis testing is something related to statistics actually. Let's see if we get time, I will discuss that. Multiple linear regression. Okay, and then there are something called as handling categorical variable, two categories. This is something which I am expecting that you people are aware about, everyone. Okay, So that's why I'll be doing what? I'll be doing what actually? I'll be going and I'll be showing you the model directly. What is multi-collinearity and how to handle the outlier values, standardization, normalization, variance inflation factor, right? And remedies for multi-collinearity, bias and variance trade-off, and then regularization. So, and then finally here, I'm going to start with the implementation of this part. So, whatever we require, not only for this algorithm, but for other algorithms also, whatever we require, all these things are mentioned in this notes. But initially, I will go with some of the basic things. Okay, and whatever the data sets you require, those data sets are also given in these notes. Whatever the data sets I will be making use actually, everything I will be sharing with you. Okay. And once the model is done for linear regression, once the model is done, what I will be doing is then I will be making the pie chart. Okay, and then I will be showing you the model actual application, web application with the help of PyCharm, and then we will go with the deployment of that particular model to cloud. For linear regression, I will try to show all these things. That's why it will take time. After that, we will start with other algorithms. It will not take much time. This is how we are going to proceed. I hope this is clear. Yes, anyone? Any question? I think someone has muted. Any question? Thank you, Vita Madam. Thank you, Abhijit sir. Okay, fine. Now, let's start with the basics here. As I said, in coming sessions, we will see in one session itself, we will be talking about 2 to 3 algorithms. But initially, as I want to make some of the things clear, that's why I will be going with some of the basic things, right? Some concepts you need to know. This is very, very important. See, linear regression, all this theory I talked about already. Right? I will not discuss about. What is this area? In my like in every algorithm, for every algorithm you will be getting separate nodes, and there you will be able to find out that at the start you will be able to see this particular diagram. It's a complete flow diagram, and that I will call it as typical life cycle diagram for machine learning. Okay, if someone wants to create a machine learning or a deep learning model, you can actually more or less will be able to see that same steps we are going to follow, whether it's a machine learning model, deep learning model, or in AI, whatever we do, more or less you'll be able to see same steps. Same steps. Okay. So maybe in short, if I want to tell you, see everyone about model development. Okay, about model development, what we need everyone initially, we need data, right? We need data. So data selection is the first step. So as I am talking about Python, and I will be showing you the implementation with the Python only. So here basically I can make use of different techniques to fetch the data. Maybe if the data is a big data, maybe data is coming from, let's say, streaming, via streaming it is coming, via some databases it is coming, via CSV files it is coming, if it is coming through batches, right? So maybe let's say suppose I am using Python, so I will use pandas kind of a package. Okay, there are different ways also everyone. Kafka one can use of if it's a big data, and so on. There are some different messaging techniques like Kafka which are available, definitely. So let's say in Python, I will use pandas to fetch data. And once data is there, we will try to go and we will try to describe that particular data, because we want to understand the data, because without understanding one cannot do anything. Even if you might be an expert, but if you do not understand the data, you cannot do anything. So we will try to understand the data. So if in case of Python, like if you are aware about, maybe you might be knowing that if we have a data frame, we have a method like describe. One can go and one can describe it like this. So basically, I mean to say, I will go and I will make a pandas package here. Anyway, in implementation, I will be running it in front of you. Okay, and then for performing some graphical and statistical data analysis, we can go and we can make use of NumPy, and for visualization, graphical visualization, one can make use of matplotlib package. All these are packages from Python, okay, or Cbond package. In my case, you will be able to see most of the times I use these packages for visualization or combination of those. So we will be going and we will be plotting some plots like bar plot, count plot, right, distribution plot, boxer whisker plot, so scatter plot, right. Generally, this is what we will be making of, and some other types of plots. So again, basic Python is what we will require here. So we fetch the data, we try to understand the data with the help of analyzing that data, with the help of visualizations, and then if necessary, we will try to transform the data. No, what do you mean by that data? What do you mean by transformation, even or data transformation? So see, data transformation means sometimes you will find out that you have some hundreds of columns, input columns, okay, and one output column, target, right? Target column, output column, label data. Now you will find out that everyone, some of the columns, some of the input columns are not at all necessary. Let's suppose if you talk about previous example, let's suppose we have a column called as initial character of the name of the person. So does initial character of the name really contribute to the salary of the person? No, that is not needed. Simply drop it. Or maybe sometimes you need to combine some of the columns. In which case you need to combine, I will talk about that. So I mean to say data transformation means if necessary add the column, if necessary remove the column, and so on. So here also we can make use of, in case of pandas, in case of Python if you are talking about, we can actually make use of pandas package. Right? And derivation of new attributes. Attribute is nothing but again column. So yes, that is possible with, so you can add a column, you can add a row, you can remove a column, you can remove a row with the help of pandas package by using concept of data flow. And once that is done, we go with EDA. EDA is nothing but what, everyone? Exploratory data analysis. Exploratory data analysis. What am I talking, everyone? I am simply talking the steps which you generally follow while creating the model before going and making use of the algorithms. So selection of machine learning algorithm based on the patterns observed in the EDA. So see, everyone, in case of linear regression, you will notice that whenever, let's say, this is the input, this is the output, with increase in the x value, if there is an increase in the y value, that means it's a linear. The nature is linear, right? It's like this. So, and in case of linear regression, we have seen that we make use of a line of base fit, and then the nature of the line of base fit, as it's a line, is always going to be straight. It's not like this. I told you already. So whenever we will go and whenever we will try to find out that with increase in the input, if output is also increasing in the linear fashion, that means that is one hint for us to go for linear regression in that case. So again, EDA also is going to help you to decide about which algorithms you can go for. Let me tell you, everyone, if you are thinking that we always go with only one algorithm, no. As I told you at the start, that we use at least 5 to 6 algorithms to solve only one problem. Initially, even though I also will be showing you only one algorithm to solve the problem, because we haven't discussed about any algorithm at all. Then we will be discussing about, let's say, 4 or 5 algorithms. Then I will go and I will try to show you how we actually make use of more than one algorithm to train the model. Okay, so wait for some time. That's why wait for some time. That is going to be cleared with hands-on. Okay, so the one point I want to talk about here is, if the relationship between input and output is somewhat linear, that is going to be one hint for us. And where we will come to know about that? Through EDA, exploratory data analysis. So here also we will go and we will make use of visualizations, and we will try to do EDA part. Okay, we will try to find out the patterns present in the data, and then sometimes like maybe that is useful for us to go and study about which type of algorithm we can actually make use of. And once that is done, we will also make sure that the data is standardized or the data is normalized. Now, just to give you a basic idea about what do you mean by standardization, what do you mean by normalization. So see, everyone, standardization means what? If I have, let's say, if I have some columns like this, okay. Now, if in the first column, second column, third column, and so on, we have some values. So here the values are in, let's say, thousands, 10,000, 30,000, right, 50,000, and so on. And here the values are like 0.01, 0.02, 0.1, 0.5, and so on. So see, there is a huge difference between the values in this column and this column and this column. That means they are not on the same scale. So what standardization will do is, standardization will try to bring them to the same scale. Why? Why to bring them to the same scale? Because if you do not bring them to the same scale, and if you try to train your model based on this kind of a data only, your model might become a biased model. Biased towards this result, this column only. That means the output column will be mostly dependent on this particular input column. And we do not want it like that, right? We don't want it to be a biased model. We want to give the equal importance to each of these columns, right? That's why we do standardization. So for doing standardization, there is a library, or there is a method actually that is called as standard scaler, which is present in Python. So what it does is, in short, in simple words, if I want to tell you, it will do something like this. Take the square root of all the values, first time, second time, third time, fourth time, fifth time, sixth time, and so on, till the difference between all these values, the values in all the columns, is as minimum as possible. Is as minimum as possible. Not necessarily that it will take the square root. And square root is one example I am giving you. Okay, maybe it will take log, let's say, and it will simply try to bring those values to the same scale. That is nothing but standardization. And what do you mean by normalization? Always remember, everyone, whenever we will be going with any model development, always remember that your data should be in numeric format. Because for scikit-learn package or your machines, data should be number, numeric format. Another thing is, just now we discussed, your data should be standardized. And the third thing is, your data should be normalized. Okay. Standardization, we have already seen. Numeric, already you know. Standardization, we already just now seen. And normalization is what, everyone? See, normalized data means the data should be symmetrical, like this. If you people are aware about basics of basic packages of Python for visualization, so maybe you might be knowing about some plot, and that is nothing but distribution plot. Okay, distribution plot. In the latest version of Python, we call it as dis plot now. Distribution plot. Okay. So distribution plot is going to show the distribution of the data. So we want this kind of a distribution. This is called as normal distribution, or we call it as a bell-shaped curve. Okay. Many of you might be knowing about this particular name, bell-shaped curve. So whenever we will go and whenever we will try to see the distribution of each of the columns, the data should be normally distributed. If the data is distributed in this kind of a manner, this is not this normalized data. This is actually called as skewed data. Okay, skewed data, and it is called as a right skewed data, or I will call it as positively skewed data. If the data is having this kind of a distribution, this is left skewed data or negatively skewed data. Okay, we don't want this, we want normalized data. And in that also, everyone, there is something called as normal distribution and there is something called as standard normal distribution. See everyone, in case of normal distribution, actually mean equal to mode equal to median. If you people are not aware about mean, mode, median, wait for some time. Maybe you might be aware about mean is nothing but the average. So in case of standard normal distribution, mean is always 0 and standard deviation is always 1. Maybe many of you might be aware of it. I am just telling you that. Okay. So this is called as standard normal distribution. So this is what we want. This is what we want. So how to get your data into normalized form? If it is not, you will see that. In linear regression itself, you will see that. You will see this. If your data is not numeric, how to get it into numerical format? We will try to talk about that particular thing in linear regression itself. And that's why everyone I told you that even if we will go and we will try to talk about other algorithms, in other algorithms also you will see that we will require these things. Because these are the prerequisites before going and passing your data as an input to any algorithm, you need to make sure that your data should be in the proper format. See everyone, going and applying the method is not difficult. As I told you, anyone can do it because direct methods are available in case of Python. So that's why it will not take much time. Just go and pass the input is nothing, right? But the thing is that whether your model will be going to give a good output, very good accuracy, that is finding out, that is very difficult. Okay, so everyone will be doing this. Standard scaler is one we will be making use of, and how to get the data in the normalized format, we will talk about that. We will have to go and we will have to check out how outlier values, missing values, and so on. We will do this. And once this is confirmed, then we will go and then we will divide our data into input and output and training and testing. So I will be discussing this particular thing also. How the data can be divided into training and testing. And then that data is going to be passed as input to the algorithm for training. Okay, and once the training is done, we will go and we will try to calculate the accuracy of the model for the seen data, okay, and for the unseen data. Okay, let's say for trained data or training data, or let's say for testing data. Generally, we try to keep some testing data also, not compulsory. If you do not want to keep anything, that's fine. But generally, we go and we test the models, right? That's why we keep some data. We'll talk about that. And yes, once your model is done, you train the model, you got the accuracy. Now you found out that the accuracy is not sufficient. So you can apply something called as hyperparameter tuning, which is very important. Hyperparameter tuning is nothing but playing or tuning the parameters of the model to increase the accuracy. And then let's say accuracy is 80%, and if you feel that it is not good, you can go and you can increase it to 85 or 86 and so on by applying hyperparameter tuning. I'll be showing it to you practically. And once the client is satisfied with the accuracy, go and save the model. Generally, we save the model, machine learning models with .pkl extensions or maybe .sag extensions. Deep learning models are saved with .h5 extensions. Okay, these are machine learning models how we save it, and this is how we save the deep learning models. So here we will be making up one package that is called as pickle package. Okay, for creating the executable files, we will be making a pickle package. We just need to import it. Okay, by default it is presented in Anaconda's file. So you will be saving the model with this extension or with this extension. And then finally, we will go and we will deploy the model on one of the cloud platforms. I'll be showing you this here. Okay. Generally, I use Salesforce.com or AWS or Azure or maybe GCP, Google Cloud Platform or Pure. We will go with the free cloud so that everyone will be able to make use of that. And yes, even after that also, production deployment, there can be testing as per the client, there can be testing also. And if there is a retraining needed, that is also done, depending on the client or between whatever is decided between both the parties, depending on that they will actually decide whether to go with the retraining approach or not. And then logging and monitoring and creating the dashboards, let's say some tools like Tableau, Power BI one can make use of, right? So this also generally I save, show, but yeah, we will not be having that much of time. Generally I show the Tableau. So even like people can go and people try to come up with some dashboards also. If it is being used in real time, a model is being used in real time. So to check the performance of the model, we can make use of some dashboards. So really good dashboards with the help of Tableau. That is also possible. So these are some overall steps, everyone, I can say. I am not saying that compulsorily these steps will be applied, but more or less definitely one point is for sure that more or less we'll be able to see the steps from these steps only. In real time also, all the steps, whatever you'll be able to see, more or less we'll be able to see these steps only. Okay, maybe here and there, the sequence might change here and there, but more or less we'll see these things only. Okay, so this is in short just an introduction about how to go and how to create a machine learning model even. And as I said, I'll be putting these files, the links for these notes in the WhatsApp group. Maybe you can download it. And I think maybe in the next session we will go and try to start with the implementation part. Uh, Maybe we will implement some of the techniques and then we will go with the implementation of the linear regression. Okay, this is how we are going to proceed. So let me know if you need it out. People who are present. Anyone in doubt here? Fine. Fine then. So maybe if you don't have a doubt, we can solve it. Anyone? Vishal sir or Yogesh sir, are you there? Anyone?
Yes, sir. Yogesh, sir, please.
Yeah, yeah. Yes. Okay. So I think they do not have any doubt, Vishal sir. Maybe for today.
Right. So feedback link is shared with you on the chat box. It will be unable till next 10 minutes. So mark your attendance and then you can leave for the today's session. Fine. For tomorrow's session, I will share the link on the same WhatsApp group. Please join on the time. Thank you, Yogesh sir, for the session. So I guess there is no.
Thank you, Vishal sir.
If any
Nothing.
participant,
Yeah.
then can post your query in WhatsApp chat box so that we can or Yogesh sir can address the issues.
Yeah, sure.
Okay, sir.
Okay. Thank you, Vishal sir. Thank you, everyone. Thank you for the questions. Let me know if you have anything. We can stop, Vishal sir, right?
Yes, sir.
Thank you once again, everyone. We will meet tomorrow.
Thank you, sir.